Mr. B. Dhanasega is working as a lecturer in Department of Information Technology, Anna University, Chennai. He finished his MCA from Urumu Dhanalakshmi College, Bharatidasan University. He finished his ME in Computer Science and Engineering from College of Engineering, Anna University. His areas of interest are multi-core programming and architecture, programming models, compiler, automata theory, cryptography, and algorithms. He is an expert in subjects like compiler design, formal languages and automata theory, analysis of algorithms. His research area is code generation for multi-core architecture.
Welcome to the UGC lecture series on computer science, and we are going to have the subject called theory of computation. We have already seen around 6 episodes on this subject. Let me start with the recap of what we have seen in the previous episode of the same subject. Actually, we have seen the epsilon NFA. It is a type of deterministic finite automata where we will be having the epsilon transitions. So, any epsilon, that is, transitions can be defined with respect to over the epsilon transitions also. So, if there are epsilon transitions available in the finite automata, then we will be calling it as NFA with the epsilon transition. The reason why it is becoming NFA means whenever there is epsilon transition, it will create ambiguity in the language recognition. So, definitely it is going to be a non-deterministic finite automata, not a deterministic finite automata. So, now the question is how the languages are recognized by the NFAs with the epsilon transitions. So, that is the first topic we had seen in the previous lecture, and the next one is, so just by having an epsilon NFA is not sufficient. So, we need to recognize the strings in a deterministic fashion. For that, we need to transform the epsilon NFA into its equivalent deterministic finite automata. So, only when, that is, the deterministic finite automata equivalent for the epsilon NFA is available, the language recognition becomes deterministic. So, we need to transform every epsilon NFA into its equivalent deterministic finite automata. We have seen a modified subset construction algorithm that will convert the given epsilon NFA into its equivalent deterministic finite automata, so that the language recognition will become deterministic. So, that is the second one we have seen in the previous lecture. And the third one is, we have seen some of the examples where we have given, that is something like epsilon NFA, and by using the modified subset construction algorithm, how do we transform it into its equivalent deterministic finite automata, those things we have seen. In this episode, we are going to have a new topic that is called the regular expressions, and the definition for regular expression, how we are going to write regular expressions, and what are the various operations which are permitted over the regular expressions. So, regular expression is one of a tool actually used for describing a language called regular language. When you are looking at the Chomsky's hierarchy, the basic language or the most preliminary basic language available in the Chomsky hierarchy is called the regular language. So, one way of describing the regular language is by with the help of finite automata. The finite automata can be either in the form of NFA or DFA or NFA with epsilon transition, anything. There is another way of describing the regular languages, that is with the help of an expression kind of tool, we call it as regular expression. So, this is the most oftenly that is used notation for describing regular expression. Instead of going for constructing the finite automata, we can simply write the expressions, in turn they will keep track of the languages which are going to be recognized by those set of regular expressions. Now, let us see that is what is going to be the definition or how we are writing the definition for regular expression. So, there are two cases available in writing regular expressions. The first one is going to be the basic part, that means how we will be building the basic components of regular expressions, and the second one is with the help of these basic components or primitives, how do we make use of some of the operators supported by the regular languages to construct more composite regular expressions. So, we have to study the basis as well as the composite cases. I will just start with the basis cases. So, the first one we are having, that is the definition for regular expression. It is going to be the language defining notation. It looks like a very simple arithmetic expression, but the difference is, as far as arithmetic expression is concerned, we have the operations like addition, subtraction, multiplication, division, etc. Okay, here is the definition for the regular expression. It is going to be a language defining notation, but how it looks like something like arithmetic expressions, something like it is going to be algebraic forms. But what we have in these kind of expressions, like any kind of arithmetic operators like plus, multiplication, star, slash, but they are actually used here, but their meanings are completely different from the way in which they are interpreted in the arithmetic expressions. If I use a plus, it is actually addition as far as arithmetic expression is concerned, but here we will be using it for some kind of union operation. And whereas when you are having that as multiplication, in the case of arithmetic expressions we will use it for binary operation, that is multiplication, but whereas here we are using it for, there is a closure operation which is going to be an unary operation. Unary, I mean there will be only one operand required for that operation, so we will be calling it as the closure operation. And even we can have something like there is a dot operation, that is for multiplication. So it's not asterisk, but we will be using the dot operation. So it is actually the concatenation operation here we mean, not the multiplication. So those set of operators are even available here also. That is the reason why we are calling it like some algebraic expressions. Some of the examples are, here you can see that two things are mentioned here. One is the pattern matching in text documents. So if you want to match a pattern in a text document, maybe some word or some other, there is string within double quotes or some kind of particular symbol, in these cases we can go for describing those kind of patterns with the help of regular expressions. And once we have described the patterns with the help of regular expressions, then we can find out whether these patterns or our document is having any string matching this pattern or not. And another useful example here we can quote here is the token description of, that is tokens in the compilers. So compiler is going to have the very first phase, we call it as the lexical analyzer, and it is going to read the symbols one by one, and every symbol it is reading it is going to be concatenated, or it is formed with the help of some kind of tokens. Tokens are the basic components for any programming languages. Examples like it can be an integer, or it can be an operator, or it can be a semicolon, or it can be some keyword. These are called the tokens, and all these things will be recognized by the lexical analyzer, that is going to be the first phase of your compilation. And how these patterns are recognized? It is only with the help of regular expressions. So if you are constructing a lexical analyzer, it is equivalent to constructing a set of regular expression for describing every token which is supported by the particular programming language. Maybe the identifiers, operators, keywords, then constants, identifiers, so many things. So for everything you just write a regular expression, and those set of regular expressions, when we are combining and forming a particular finite automata, we can call it as a lexical analyzer for a particular language. So that is a major application of writing regular expressions. But not only that, anything we want to match with any kind of the text document or something like directory matching, anything, we can make use of the regular expression for describing all these things. And another point is, what is going to be the language recognized by these kind of regular expressions? So regular expression is an alternate tool equivalent for a finite automata. The language of a finite automata is regular language. So by default, the language described by any regular expression is also called a regular language. There is no difference on that. So whether it is going to be a finite automata in NFA, and that is non-deterministic form, or it is going to be a finite automata in deterministic form, or it is going to be a regular expression, the language recognized by all these are going to be only a regular language, that is a basic language available in the Chomsky's hierarchy. Now let us see how we are writing the regular expressions. So it is having two components. The first one is what is the basic set of regular expressions, and another one is going to be the composite cases, that is how do we build very complicated regular expressions with the help of operators and the bases. I will start with the basis cases. It is going to be, the first one is the regular expression which is going to be used for constructing empty language. So we have, that is pi. It is actually going to be a regular expression, or you can even call it as a notation, and what it describes is going to be the empty set. So here we have to understand what is the meaning of the empty set. So we have nothing, we are having a language, but it is not at all having any string. Even if you find an empty string in the language, it is not going to be a empty language. Empty language means there is no question of having any string. So there is no other way of describing an empty language. You use the notation phi, that is actually a symbol. As far as this context is concerned, it is not considered as a symbol, it is a notation which will describe the empty language. So if whenever we want to find out describe an empty language, you simply write it as pi. So that will be the regular expression we can immediately understand that the regular expression is going to have the language which is empty, that is not even having the symbol, that is pi. So, we should not see that pi here as a symbol, we see as a notation which describes the empty language. And the second case is we have epsilon. So, epsilon is going to be a regular expression. So, here is the case, suppose if you want to recognize empty string. So, empty string is the one in which there is no position for storing any symbol. It is going to be a string, but how many symbols we are having in that string is going to be 0. That is what, there is no symbol position available for storing any symbol. So, 0 number of symbols, the string length is going to be 0. So, how do you describe that? Once again, we can't use any symbol for describing this kind of languages. So, you go for some notation that will describe the language which is not going to have, that is, any non-empty string. So, when you are talking about the language, it is going to be set of all strings. So, if I am talking about empty string, there is no point in going for multiple empty strings, there is only one empty string, and what that string is going to be, it is a string containing 0 number of symbols, and how to describe that is with the help of epsilon. So, both pi as well as epsilon are notations for describing one empty language, and another one is going to be a language containing empty string. A language containing empty string is not empty, because it is having already one string whose length is going to be 0, that means no symbols available in the string of that language. The third case is going to be, we have a symbol called a. So, this is going to be a symbol here. It means that we can have any regular expression which is going to have a symbol called a. Suppose if you want to recognize an operator called plus, so plus is a symbol there is no other replacement for that plus. Plus wherever it is there, we have to recognize as such. So, what is the regular expression for describing plus? It is going to be plus only. So, that is the symbol. Now, the plus as a regular expression, what will be its language? The language of that plus is going to be only plus, because there is no other, or plus is not at all denoting anything else. Plus denotes itself, that is plus is an operator. So, plus will recognize only plus. So, the output is going to be the language containing only plus. Suppose if I am having something like a variable like d I am telling. So, d, if the meaning given for d is going to be set of all digits, then wherever I am using d, it is going to have any digit either 0 or 1 or anything up to 9, but where the meaning is going to be a different scenario. So, here a as a symbol, the language is going to be only a, and the string is going to be a only. So, the output is going to be a language containing only one string, and that string is going to be a only. So, these are the 3 number of that is primitive cases. So, we started with the pi, which is describing the language empty, and the next one is epsilon, describing the language containing empty string only. The third one is a symbol a, which contains the language with only string, that is a. This a can be anything. I will continue this lecture after a short break. Welcome back. We have seen the 3 cases of primitive regular expressions. One is for empty language, another one for empty string is the only language, that is third one is going to be a language containing only a symbol, that is a. So, now the question is, how do you form there is very big complicated regular expressions, or how do you form regular expressions for very big languages? So, we have to depend on some kind of operations. So, we have to study what are all the operations supported by regular languages, and we call here it as composite cases. We shall see that is how we are forming the composite regular expressions with the help of the basic regular expressions. The 3 cases we have already seen the basic cases. Now, the question is, how do you form composite regular expressions? 3 operations we are describing here. One is going to be the union operation, where we will be selecting one of the string from the arguments, and the second one is the concatenation. We will be selecting a string from the first regular expression, immediately followed by that we will be selecting a string from the second regular expression. And the third one is going to be the closure. We have a pattern, and if you want to repeat it as many times as we want to have, then we will go for a closure case. So, the first 2 are the binary cases, and the third one is going to be an unary case where we need only unary operation. Let us see first of all how do we form a regular expression from the given regular expression with the help of union operation. So, we are taking two number of regular expressions, one is R and another one is going to be S, and both are regular expressions. It can be either a simple regular expression or a very complex regular expression, and we know that the language recognized by R is going to be a regular language, and the language recognized by S is also going to be a regular language. Both are regular expressions. Now, the question is how do you form a new language which will be containing strings from R or strings from S. So, now if you want to have a new language, that is L of R plus S, so what do we expect out of that is it can have any string from L of R or any string from L of S. We are not talking about the repetition of strings, but we are talking about either a string from the L of R or the string from L of S exactly once. So, the regular expression we wanted to have for the description of L of R union L of S is R plus S. It means that you write the regular expression 1, that is R, followed by the operator plus, followed by the second regular expression. So, now this is going to be a new regular expression. Hereafter we do not call this as two different regular expressions, it is going to be a new regular expression, and what is the language denoted by the new regular expression is going to be L of R plus S, that is nothing but L of R union L of S. So, the actual meaning of this is going to be either a string from L of R or a string from L of S. So, suppose if there is a need for describing the set of all binary operators in C language. So, if we have the operators like there is plus is there, then minus is there, then star and slash. So, now the question is how do you describe the entire set of operators? If you want to describe only the operator plus, then we will write the regular expression plus, and if it is going to be a semicolon, we will write semicolon as the operator or regular expression. It will describe only semicolon. Now, the question is we want to have a regular expression which is capable of describing any binary arithmetic operator. So, we want to form a composed regular expression that can recognize any binary arithmetic operator. So, plus R minus R multiplication, that is going to be star R slash. So, if this is going to be the regular expression, then any binary arithmetic operator will be matched by any one of this regular expression. So, if you are given a regular, that is pattern which is having a binary arithmetic operator supported by C language, then immediately this pattern will say it is available, otherwise it will say that it is not going to be available. So, in these kind of scenarios, or even you think about the set of all digits, if you want to recognize set of all digits, then it should be either 0 or 1 or 2 or anything up to 9. So, how do you form the new regular expression? The new regular expression is formed by 0 or 1. Here the operator which we will be using for R is going to be plus. So, it is going to be 0 plus 1 or 2, I mean that is plus 2 plus 3 and finally it is up to plus 9. So, the entire regular expression now we are having is capable of describing any one digit. It is not going to be any sequence of digits, it is going to denote any one digit. And suppose if you want to form an integer out of this, with the help of only this particular expression, you can't form any integer with more than a digit, but you can form any integer with one digit, because even a single digit is also going to be a integer, so that is possible. So, now let us see the next operation, it is going to be the concatenation. Suppose if you are having two regular expressions once again, that is R and S with their corresponding languages as regular languages. If you want to have a new string, that means it is actually formed out of the concatenation from a string from R, that is L of R, and a string from L of S. So, now the question is what kind of regular expression is capable of describing that concatenation? It is going to be R dot S. Generally that dot will be removed out of the regular expression. So, by default if you are writing two regular expression in the continuous manner, it is going to be a concatenation. So, the meaning is this regular expression is going to recognize a new language. It is formed by concatenating a string from L of R, that is a string from the first regular expressions language, and a string from L of S, that is a string from the second regular expressions language. You concatenate those two strings in the same order, So what do we get actually is going to be the set of all strings which are formed by the concatenation of L of R and L of S. So once again, if you are looking at the example perspective, think about the keyword IF in a programming language. So for generating that IF, definitely we need some concatenation. The first symbol available in I is going to be, that is IF is going to be I, and that will be recognized by a regular expression I, that is a primitive case. Similarly, you form another regular expression which is capable of recognizing F. The regular expression capable of recognizing only F is going to be F only. So now to recognize the keyword IF, we need to do a concatenation operation. The concatenation operation is done by I, that is followed by immediately writing F. So the language of I is I, the language of F is F. So now the concatenation will give you the keyword IF. Similarly, you can concatenate any number of symbols or even any number of strings, but the condition is the order is very important. If the regular expression is written as R immediately followed by S, then we have to take the first string only from R and the second one only from S. The order should not be changed. If you change the order, then it is going for a new regular expression. Suppose if you want to select something from S initially, then you write a regular expression as S followed by R. So the order is very important, and no need of writing any explicit operator for describing the concatenation operation. The third one is the repetition. If you want to repeat a pattern for any number of times, we will be having an operator called closure. So if R is going to be a regular expression, and if you want to repeat that particular R for any number of times, then we want to have a new regular expression called R star. So by the notation itself, we find that it is having only one operand. The operand is going to be R. So R star is going to be a new regular expression, and the language is called the closure of that R. So how do you write the language? So it is going to be L of R. That means you take a string from, that is the language of R, and you repeat it as many times as we want. The closure's meaning is going to be 0 or more number of times. Suppose if you want to form a string of symbols from A to Z, then you write the regular expression. First of all, it is A to Z, that is A or B or C or D, anything up to Z. Then over that A, you just put an asterisk. It means that the closure. So you can take any symbol any number of times, or suppose if you want to form an integer can be one digit or more number of digits. So now we can make use of the closure as well as concatenation to form a valid unsigned integer. So what we should do is, if you are simply writing D star, one of the string is going to be that D 0 number of times. When you form the D 0 number of times, the resulting string is going to be epsilon. Epsilon is empty string. So an empty string cannot form a valid integer. So how do you avoid the generation of that empty string is by concatenating D with the D star. So it will ensure that at least one time D is there, then followed by that we can have any number of digits depending on the need. So what that D here denote is going to be any digit. So one digit followed by 1 or more number of 0 or more number of digits. So now you can form any number of valid integers. So that is a place where we need really a closure operation. Without the help of a closure, you can't repeat or you can't generate strings with repeated number of symbols. So there is another variant of that closure, we call it as positive closure. It is generated by using an operator plus. So if I am writing D plus, or if it is going to be R plus, the meaning is R repeated 1 or more number of times. The difference in between R and plus is any that is string, that is D followed by D star can be written as D plus, or R followed by R star can be written as, that is R plus. So 1 or more number of times we go for a positive closure, and if it is 0 or more number of times you go for cleans closure. The default closure is called cleans closure. Other than that, we are having one, that is regular expression description, which is normally used for the change of priorities. Suppose if you are having some regular expression like A, B or C, that is A followed by B immediately or C. The meaning is a string AB or C. Suppose if you want to have a new regular expression in which the resulting strings can be either AB or AC. Instead of AB or C, we want to have A, B or A, C. So, now we definitely need some kind of change of priorities. By default, the priorities are concatenation is going to take that is the maximum priority, and then it is going to be the union operation. If it is asterisk, then it is going to be the that is highest priority operation because it is having only one operand. Other than that, concatenation takes highest priority and plus takes lower priority. If I am writing A, B or C, the resulting strings are A, B or C, but my intention is A, B or A, C. So, what should I do is just put B, C inside bracket. So, what will happen is the priority for plus is now more than the priority for concatenation. So, automatically we will be getting A, then we can have B or C. So, if it is B, then we will get AB as the resulting string, and if it is C, we will get AC as the resulting string. So, in these kind of situations, we want to have a regular expression with bracket. Actually, it is not changing the language of that is anything. Suppose if I am writing R inside bracket, there is no difference as far as language recognized by that R is concerned. But where it makes difference is whenever it is used in the context of some regular expression where we are having more number of arguments, then definitely it will make some change on the language, because of changing priorities will change the language of the automata also. There is a language of the regular nature also. These are all the operations we are having as far as our regular expressions are concerned. So, by using these kind of operations, we can construct any regular expression for describing any regular language. So, now we have some of the identities for regular languages. That is, if I am having regular expressions, and that is how do you form the there is new complex regular expressions with the help of that is our already existing operations. The operations we have seen are that is like the plus, it is going to be the union, or it is asterisk for the that is closure, and another one is going to be the dot, which is for the concatenation. So, before looking at the various identities, let us see some of the examples available in the there is regular languages. You can say that set of all integers, it is going to be a there is regular expressions or regular language. The set of all keywords available in a programming language, that is going to be a that is regular language, or the set of all operators, that is also going to be a regular language. Or you can think about the strings of the form something like a power n, that is visiting a for any number of times, or a power n followed by b power m, where n and m are not at all related. That is very important here. If n and m are related, this cannot be a regular language. Here n and m are not related means it is not going to be a regular language. These are the few examples available in regular languages, and as a summary, what we have seen is the definition for regular expressions, and then we have seen how we are writing regular expressions, and with the help of the regular expressions we will be able to define any regular language. And the various questions are, you may be asked to write any that is regular expression for a set of language. We may be given a set of language, maybe the set of all floating point numbers, that is going to be a language, or the set of all signed numbers, that is going to be language, or the set of all operators available in language, that is going to be a regular language. And whenever we find that the language is going to be finite, automatically the language becomes a regular language. So, you may be asked to write regular expressions for that is any regular language, either it can be a finite language or an infinite language. Suppose if it is going to be set of all integers, maybe it is looking like a very simple language, but really it is not going to be a finite language, it is infinite number of integers are available. So, these are all the possible questions we can have in this domain. With this I conclude this lecture. Thank you all.